Welcome to video 2.5, your introduction to standard deviation. Yesterday we worked on deviations from the mean, and now we are going to see how we can apply those deviations to describe the entire distribution as a whole. So some vocabulary you need to get down first. What is standard deviation? Standard deviation describes the deviation from the mean or variability for an entire distribution. So yesterday we looked at individual data points and their deviation from the mean. Today we're going to show how we can show that for an entire distribution. We can use the standard deviation to describe data sets, make predictions, and interpret the normalcy of distributions and their data points. It's a very useful tool, and you will be required to use it for your second problem set. This is a really important rule to remember. Usually the larger the range of a deviation of a distribution, the larger the standard deviation. So let's say that the range, remember the range is taking the lowest number, the minimum, away from the highest number, the maximum, and finding that difference. Usually the bigger the range, the bigger the standard deviation, or the greater the spread of the data. So if something had a range of 1, that would be a very, very small standard deviation, but if something had a range of like 99, that would be a very large standard deviation, a very large spread. And this is the most important thing to get down here, your formula for finding standard deviation. I know this looks really complicated right now, but we're going to break down each step, and I'm going to tell you what all of these symbols mean as we go through it. So the steps for calculating standard deviation, you must get them down, are to first find the deviation for each data point. And you can see that by this part of the formula right here, x minus the mean. We did that yesterday. You all know that means the deviation. Then we get into this step here with the square, and you have to square each of those deviations. Then you find the mean of the squared deviations, and you do that by dividing the mean by n minus 1. So this is a little different than what you're used to dividing by n minus 1, because it's taking one data point away from dividing by the true mean. And we do that to just make it a little more specific and accurate. So let's say there were 7 data points that you added up in a distribution, you would divide by 6. If there were 8, you would divide by 7. If there were 15, you would divide by 14. So that's all that means. And then once you divide by that n minus 1, you take the square root of everything. And this step right here shouldn't say the mean. This is how you find the mean. So you don't divide the mean by n minus 1, you divide by n minus 1. Sorry for that. Make sure you fix that in your notes. So you're going to see questions like this. Here's a dot plot of the lives of brand A batteries from lesson 4. We all know that from yesterday. What's the variability of this distribution? We can describe it in words, but we don't have a number to put on it. But there is a way we can put a number on it, and that is by finding the standard deviation. The standard deviation allows us to put a number or a value to the variability of a distribution. So let's get into it. First, we need to find the deviation for each data point. And in order to do that, we need to find the mean of this data set right here. And the mean for this, so let me write it, the mean is about 101.2. If we add them all up, it's 607, and then we divide by 6, and that's where we get 101.2 from. So we have to take each of these data points and subtract the mean from them to get our deviation from the mean. So I put in all those deviations from the mean, and now we're getting into how this standard deviation process is different. So at step 2, we have to square each of the deviations. So if you look on your calculators, you will see a little x squared button, or whatever calculator you're using. You can also just multiply negative 17.2 times negative 17.2. Squaring a number is just multiplying it by itself 2 times. So negative 17.2 squared is negative 200. It shouldn't be negative. It's positive. I'm sorry. 200. I'll fix that. 200 and 95.84. Negative 7.2 squared is 51.84. Negative 5.2 squared is 27.04. 4.8 squared is 23.04. 11.8 squared is 139.24. And then 12.8 squared is 163.84. You are done with step 2, and we're going to keep moving. So on step 3, we need to find the mean of the squared deviation. So that means I have to add all of these up. Remember, this should actually say add the squared deviations. I'm sorry that that's not correct typed out. Should have checked it before I put it into my lesson, but yes, that should say add the squared deviation. So we're going to add them all up, and we get 700.84. And the part of our formula that says the sum, this symbol right here means sum. So in your formula it says the sum of the deviations squared. That's that top part of your formula under the square root sign. This is why we're adding them up. This is the part of the formula that we're doing right now. And now we are at step 4, which is to divide the sum, I should say sum, by n minus 1. So I see 1, 2, 3, 4, 5, 6 data points. I'm going to divide by 6 minus 1. So I'm going to divide 700.84 by 5. And for that we get 140.168. And I'm at my last step now, step number 5, which is to take the square root of that. So you can do that right on a calculator. We take the square root of 140.168, and we get 11.8. So our standard deviation for this data set is 11.8, and that means that you can expect the typical battery life for the battery that you're buying of this brand to last anywhere from the mean of 101.2 hours, take away 11.8, or add 11.8, anywhere between that range, and we'll see that on the next slide. So as I was saying, since our standard deviation is 11.8, we found the typical distribution from the mean for battery life of this brand. If you use a battery from this brand, you can expect it to fall within one standard deviation of the mean, and that means that it will last between 89.4 hours and 113 hours. And how we got that was we took the mean of 101.2 and we took away our standard deviation of 11.8 and got 89.4, and then you also have to add a standard deviation in the positive direction, and we got 113. So anywhere between 89.4 and 113 hours is within one standard deviation of the mean, and you can expect your battery to last that long. Standard deviation helps us to analyze the data points compared to the entire distribution. So your how question, I understand this is a very complicated and heavy subject, and we're going to spend a few days on it in class, but do your best in answering this question. The scores for 8 math quizzes, and that is not 8, that is 6. 6 math quizzes are below. What is the standard deviation for this data set? So do your best, follow the steps of that we corrected. So step 3 and 4, step 3 should say that you add up all the deviations, and then step 4 is to divide the sum of the deviations by n minus 1. Make sure you have that corrected step, and then you take the square root after that. Good luck, and I'll see you tomorrow.